Hello everyone. Today we are discuss the next numerical of equilibrium. Now this one, if this diagram is like this and we want to find out the unknowns, so first of all read that numerical. Two cylinders of masses M1 100 kg and M2 50 kg are connected by a rigid bar of negligible weight hinge at each cylinder. Determine magnitude of force P for equilibrium. Now for this diagram we want to find out this force P. Okay, this force which kept this diagram or this adjustment in this equilibrium position. It's because of P force these two spheres are in equilibrium. Okay, this P force having the angle with horizontal 45 degree. Okay, now M1 mass of M1 is 100 kg, means which is having the A sphere, bigger sphere, and smaller sphere is M2, that is 50 kg mass. Okay, now here we have to draw the separate FBD for two sphere A and B. Now here imagine that if P is not there, P force is not there, now this because of this weight of this bigger sphere and attachment because of this rod is attached at the point A and B with a pin or hinge. Okay, now because of weight of this bar, this sphere push this B sphere in the upward direction, means in this bar the force is for the B point that towards the B point and for the A towards that A point. So this is the force developed, compressive force is developed in this sphere, in this negligible bar. Okay, so draw the FBD of this spheres A and B separately, and this force, compressive force for B point and compressive force for A sphere, okay, in that bar which is having the angle 15 degree with horizontal. Now this inclined plane having the angle 60 degree. So here contact means contact reaction is there. Suppose let that reaction is one reaction which is perpendicular to this surface. So reaction is having perpendicular means 90 degree. This is 60 degree. So reaction angle with horizontal is must be 30 degree. Similarly here R2 is the reaction. So that reaction is perpendicular to this point B. So this reaction 90 degree having the angle with this inclined plane, this angle is 45 degree. So reaction having the angle 45 degree with horizontal. So by finding out all the angles, draw the FBD separately. Now this is the FBD. Weight of this sphere, mass is given, so multiply that mass into 9.81. 100 kg is a mass, so into 9.81 is 981 Newton or weight, that is acting in the vertically downward direction. Here reaction, as we already discussed here, R1 which is having the 30 degree, okay, at this point or at the center of the sphere, and this force, compressive force, let that force is F, okay, towards the point A which is having the angle 15 degree. Similarly for B, weight of the sphere B, this force, compressive force, angle is 15 degree. That P force which is having the angle 45 degree with horizontal, that is given in the numerical, and this reaction, contact reaction, okay, with inclined plane, so R2 which is having angle 45 degree. Now we want to find out the force P. So if we apply the FBD or we solve this FBD B, to count the number of forces, 1 2 3 4 forces. All these forces are concurrent forces. So we have the equation, two equations, summation of x, summation of y, and unknown are P is one unknown, F is unknown, and R2 is unknown, three unknown. Equation 2 and unknowns are 3. So we can't solve this B sphere first. Now take this sphere A, count the number of forces, 1 2 3, three forces, concurrent forces. So concurrent forces and three forces under equilibrium, we can solve this by Lami's theorem. So Lami's theorem से हम ये find out करेंगे. यहाँ पे unknown R1 and F, two unknown. By Lami's theorem we can find out the two unknown. Now from A sphere or AFBD, we get the value of f. Now put that value, same value at the for the sphere B FBD, and find out the then unknowns are less, only P and R2, two unknown, two equations. So we can solve this B sphere FBD. So solve first of all AFBD. For AFBD, that's use the Lami's theorem. So for Lami's theorem, draw all the forces away from the joint. This force is second quadrant, which is having an angle 15 degree with horizontal. This is downward force and this is first quadrant force. So draw likewise. Okay, this is the FBD of A. Okay, and FBD of simplified diagram of sphere B is this one. Okay, for the second we can solve that after this. If we find out the F from A, put this value here and then we can find out the B sphere. Okay, now apply the here Lami's theorem. Lami's theorem, for that find out the angle between the forces. Okay, now R1 divided by 105 sine of 105, F divided by sine of 120, and 981 divided by sine of 135. Now if we want to find out the R1, equate first and second and find out the F value second and last. So by equating likewise, simplify that, can do the calculation, we get the RA value, R1 value and F value. Now this is the positive, means we assume that this is a compressive force. So our assumption is correct. So this is the compressive force. Now put this value F from A sphere FBD in the that second FBD of that B sphere. Okay, by putting this value F here, now count the number of forces 1, 2, 3, 4. Summation Fx and summation Fy. Two equations, we have 4 forces, concurrent forces. So we have the two equations. Solve one by one. First summation Fx. Now F is x component of x plus F cos of 15 minus R2 cos of 45 minus P cos of 45, and this force is vertical, so 0. Only here that P force P and R2 is unknown. F force value यहाँ पे हमें लिखनी है, पुट करनी है from A sphere FBD, वो हमने जो अभी कैलकुलेट की, and simplified that in the terms of P, because ultimately हमें our aim to find out the P force. So in terms of P, write on the equation number 1. Now summation Fy, y component minus downward component F minus F sine of 15 plus R2 sine of 45 minus P sine of 45 and minus 490.5. So simplify that equation. Okay, again find out the value of R2 by this equation and put this R2 value in the equation number 1, or we can solve this two equation in P and R2 unknown by on the calc. We can solve that likewise. So इस step से भी हम कर सकते हैं. So value यहाँ पे हमने P के terms में निकाली है second equation में, और R2 की value यहाँ पे put की, तो only P is unknown. So solve, simplified this equation number 1 and we get the value of P 253.9 Newton. Next numerical. Determine required length of cord AC so that 8 kg block is suspended in position shown in the figure. The undeformed length of the spring AB is 0.4 meter and has a stiffness of 300 Newton per meter. We want to find out here, for this diagram, we want to find out this length of AC. हमें length of AC cord निकालनी है. 8 kg का weight attached है at point A. Okay, now हमें AC की लेंथ अगर चाहिए, सो अगर ये डायमेंशन यहाँ पे हॉरिजॉन्टल डायमेंशन CB का 2 मीटर गिवन है एंड एंगल यहाँ पे है, तो विद द हेल्प ऑफ दैट वी कैन फाइंड आउट द लेंथ ऑफ AC. सपोज इसका यहाँ से अगर मैंने एक वर्टिकल लाइन ड्रॉप की एंड दिस कंटिन्यू डॉटेड लाइन कंटिन्यू की, तो ये राइट एंगल ट्राइंगल बन जाएगा. इन दिस राइट एंगल ट्राइंगल एडजेसेंट साइड, दैट इज द एडजेसेंट साइड इज h cos theta AC, means that is the hypotenuse of this right angle triangle. So h cos 30 degree. So AC cos of 30 degree यहाँ पे जो मिलेगी, so ये अगर लेंथ मुझे मिल गई, so from this 2 मीटर, so ये माइनस करने के बाद में मुझे ये लेंथ इजीली मिल जाएगी। ये लेंथ मिलने के बाद में वी कैन फाइंड आउट दैट AC लेंथ। सो अभी क्या करना है, मुझे लेंथ AB की फाइंड आउट करनी है। नो AB की लेंथ डायरेक्टली that spring undeformed length of the spring here AB is given 0.4. So this is the undeformed length? No, it is not an undeformed length. Because of this 8 kg mass, this spring is stretched. So this is not a 0.4 meter. This is stretched. तो ये लेंथ बढ़ गई है इस वेट की वजह से। तो हमें ये लेंथ फर्स्ट ऑफ ऑल फाइंड आउट करनी है। उसके बाद हम ये लेंथ फाइंड आउट करने के बाद में फिर 2 में से ये माइनस कर देंगे, मुझे इस हॉरिजॉन्टल लेंथ मिल जाएगी एंड देन AC की लेंथ मिल जाएगी। सो पहले हमें क्या करनी है, स्प्रिंग की लेंथ फाइंड आउट करनी है। तो एंड ऑल्सो ड्रॉ ए FBD एट द A पॉइंट। तो FBD कैसे निकलेगी, दैट फोर्स इन द स्प्रिंग इज अवे फ्रॉम द A पॉइंट, force in the spring force in this rod is that away from the A point and weight 8 into 9.81. okay, so ये है FBD of this at the A joint. okay, force in the AB, force tension in AC, and this is the weight. So by Lami's theorem we can get force in the spring AB, okay, and tension AC. okay, by applying the Lami's theorem, find out the angle between that two forces. okay, do the calculation, find out the force in the AB and tension AC. Now use this force in the AB is 135.93. okay, now we have the one formula, tensile force in the spring AB is equal to FAB is equal to K into X. K is, that is a coefficient of spring, and X is the stretch length of the spring. okay, now force, we have the force in that spring and coefficient of that spring is also given in the numerical, that value, and we get the X from this equation. So X here by this equation, yeah, we get this length. okay, now stretch length of the spring AB is equal to original length plus stretching कितना है, that is equal to X, this X. So undeformed length is 0.4 and stretching length is this one, stretch length is this one. So complete length of the spring AB is equal to addition of L0 plus stretched length. okay, so this is the length of the AB. now if we get the length, so 2 में से माइनस कर देने के बाद में हमें मिलेगी that adjacent side of that AC. so adjacent side is AC cos of 30, okay, is equal plus AB is equal to 2 meter. so AB हमें यहाँ पे मिल गई है, that is 0.853. so उसमें से माइनस करने के बाद में एंड डिवाइडेड बाय cos 30 करने के बाद में मुझे मिलेगी AC की लेंथ, या फिर बाय ज्योमेट्री यहाँ पे AC cos 30 प्लस AB इज इक्वल टू 20, यहाँ पे जो है दिस लेंथ, एंड ये उसमें से माइनस करो, डिवाइडेड बाय cos 30 करो, AC की लेंथ मिल जाएगी, लाइक दिस. सो दिस इज द आंसर. Length of the AC is 1.324 meter. Now next numerical. 2 cables tied at C as shown in the figure. Knowing that maximum value of tension in the cable is 1000 Newton, determine magnitude of largest force P which may be applied at C and the corresponding value of theta. Means we want to find out this P force and this theta value, okay, for this given diagram. okay, now see, if you observe the C joint, here forces are 1 in the cable BC, in the cable AC, and P force. 3 forces at joint C. Draw the FBD of this according to that given condition. okay, find out the angle between these between the forces and apply the Lami's theorem. Now by Lami's theorem we get that tension BC divided by this angle, okay, complete angle, tension AC divided by this complete angle, and P divided by 95. Now to find out the value of that P, largest value of the cable that subjected to maximum allowable tension is 1000 Newton. Means P tension in the BC and tension in AC, that is the equal to 1000 Newton. दोनों की value 1000 Newton है. So if a numerator are same, so denominator we can equate that denominator. okay, so denominator must be same. उसका दोनों की वैल्यू भी सेम होनी चाहिए. सो इक्वेटिंग दैट टू साइन गेट कैंसल्ड. ओके, सिंप्लीफाइड थीटा कलेक्ट करो एंड दिस टर्म्स इज इक्वल टू, देन वी गेट द वैल्यू ऑफ थीटा that is equal to 77.5 degree. Now put that in that equation, above equation. So above equation theta is this one. So by putting that we get the P max, that is equal to 1080.94 Newton. So this is the solution of given question. Next, a bar 12 meter long and of negligible weight is acted upon by forces as shown in the figure. Determine angle theta for equilibrium of the bar. Now for this position of the bar, we want to find out this angle theta. This vertical force, horizontal forces are given. Okay, and here slope of this inclined plane at B point is given 3/4, and also distances AC, DC and BD, that is also given here. We want to find out this theta. Now again, first step is the same. Draw the FBD. So here for this FBD, these are the external forces. Draw as it is. Then at this point A, inclined surface is vertical. That surface is vertical. So reaction or contact reaction at point A is horizontal reaction at towards the A point. Now here B point, this plane is inclined. So here one reaction which is perpendicular to this surface के लिए perpendicular है. So here reaction पहले सबसे पहले इस plane का angle निकालो, that is equal to tan this angle, and this angle must be same. So tan inverse of 3/4 is equal to 36.86 आएगा ये angle. Then this reaction is perpendicular to this surface. This is 90 degree. This is 36.86. So reaction having the angle with horizontal, that is 90 plus 36.86 minus 180 में से ये addition minus करो, you will get the reaction B, RB angle with horizontal. Okay, so likewise draw the FBD of this complete diagram. So this is the FBD. RA 200 downward force, vertically downward. At D point, horizontal force, and here this force. Here alpha, tan alpha 3/4, 36.86. Remember always this value 3/4, tan inverse of that quantity, the angle is same, 36.86. So write down that equation and without calculation write down that value 36.86. Okay. Then RB, which is inclined, this having 90 minus alpha is this one. So this is inclined force, so make it a components, a horizontal and vertical component of that RB. This is second quadrant force, so minus left में जाएगा एक component upward जाएगा. Now count the number of forces. 1 2 3 4 forces, not concurrent forces. So we have the three equations, summation fx 0, summation fy and moment 0. So apply one by one and we want to find out RA, RB and theta. Three unknown, three equations. We can solve this by three equation. Okay, so apply one by one. First of all, summation fx. RA minus 100 minus RB cos of 53. Okay, तीन ही horizontal forces है, write down that. Okay, now simplify that. ये 100 इस side में लेके आओ, simplify that and write down the equation number 1. After that summation fy apply करो, minus 200 plus RB sin 53.13. So we hear from this equation only RB is unknown, so simplify that equation and we get the value of RB. तो RB 250 मिला हमें उसकी value magnitude. Put this value in equation number 1. So calculate that and we get the value of RA. तो हमें यहाँ पे RA की भी value मिल गई, RA RB दोनों की value मिल गई. Then theta हमें यहाँ पे फिर भी बचता है. So apply the third condition. Summation moment at B point is 0. Now here summation moment at B is 0. So RB is passing through the B. So its moment is 0 क्योंकि perpendicular distance 0 है. Now horizontal force, ये vertical है, ये horizontal है. So horizontal के लिए this is the vertical, is the perpendicular distance. वर्टिकल के लिए एफ बी इज द परपेंडिकुलर डिस्टेंस हॉरिजॉन्टल, एंड हॉरिजॉन्टल आर ए के लिए ए एच इज द परपेंडिकुलर डिस्टेंस. ओके, नाउ calculate the summation moment. First of all, this 100 Newton force. This force is rotating anti-clockwise direction about B, in anti-clockwise direction. So 100 into DE. So DE, if we consider this triangle, this right angle triangle, in this right angle triangle this is theta, ये theta है, मतलब इसका ये भी angle theta होगा, and राइट एंगल ट्राइंगल की हाइपोटेन्यूज कितनी है 4. सो DE जो है परपेंडिकुलर डिस्टेंस 100 के लिए, दैट इज द अपोजिट साइड ऑफ थीटा, सो दैट मस्ट बी 4 साइन ऑफ थीटा. ओके, सो ये 4 साइन ऑफ थीटा है DE, 4 साइन ऑफ थीटा. नाउ दिस 200, दिस फोर्स इज अगेन रोटेटिंग एंटी क्लॉकवाइज डायरेक्शन, वर्टिकल फोर्स. सो दिस हॉरिजॉन्टल FB इज द perpendicular distance. Now in this triangle, right angle triangle, बड़े वाले triangle में hypotenuse is 3 plus 4 7, and we want to find out the adjacent side of this theta. So 7 cos of theta, 7 cos of theta. Okay, and RA, this force is rotating about B in clockwise direction, minus RA into perpendicular distance AH. Horizontal के लिए AH is the perpendicular distance. Now AH, अभी count करो ये बड़ा triangle. In this triangle, hypotenuse is 5 plus 3 plus 4. Okay, complete, that is the 12. So we want to find out the opposite side. AH में मतलब थीटा के opposite side है. So that is equal to H sin of theta. H is 12 sin of theta, 12 sin theta. Okay, put all this value in this equation, summation moment, इसमें वैल्यू पुट करो सारी, एंड सिंप्लीफाइड दैट, सिंप्लीफाई करके जाओ, साइन थीटा अपॉन कॉस थीटा इज इक्वल टू tan थीटा. ओके, और ये दिस डिवाइडेड बाय 2600, सो दैट इनवर्स tan थीटा, इनवर्स ऑफ दिस क्वांटिटी, you will get the theta, that is 28.3 degree. So that is the answer of this question. Thank you.